Hello everyone, welcome to In 5 Minutes. In this video, we are going to solve one sum that is based on decimation in time radix to fast Fourier transform butterfly sum. So let us have a look on question. The question is, compute the 8-point DFT of the sequence x of n, that is 1 by 2, 1 by 2, 1 by 2, 1 by 2 and the rest all are 0. We have to use the radix to decimation in time FFT algorithm. We will draw the flow graph, that is the butterfly diagram, and solve this sum. But first, let us see the different values of twiddle factor. That would be w8 raised to 0 is equivalent to e raised to 0, that would come out as 1. w8 raised to 1 is equal to e raised to minus j pi by 4, that is 0.707 minus j 0.707. And w8 raised to 2 is given as e raised to minus j pi by 2, that is minus j. And w8 raised to 3 is equal to minus 0.707 minus j 0.707. Now, we can solve this in two ways, like solving the equations directly of output of stage 1, stage 2 and stage 3, and another way is to solve by butterfly diagram. But in exam, it is necessary to write all the equations, so it gives basically the explanation of the butterfly diagram. First, let us draw the flow graph and then write the equation. So let us have a look on flow graph. Now basically this is the flow graph. Now this is the stage 1, stage 2 and the final stage, that is stage 3. We will go stage by stage. Now let us focus on stage 1. On stage 1 the inputs are x of 0, x of 4. Remember that these inputs are in bit reverse order. So x of 2, x of 6, x of 1, x of 5, x of 3 and x of 7. Now the next step is to write the multiplying twiddle factor in the first stage, that would be w8 raised to 0. w8 raised to 0 is 1. Now we will join the butterflies and let us see what the stage 1 gives as an output to the stage 2. So at the first stage, let us draw the butterfly diagram. Always point out the directions of the flow and always write the multiplying factor, that is 1, and when the butterfly ends there, it is a minus 1. Similarly, it applies to rest of the butterflies. Now this is how we have drawn the first stage. Let us write the output of the first stage as S1 of 0, S1 of 1, S1 of 2, S1 of 3, S1 of 4, S1 of 5, S1 of 6 and S1 of 7. Now corresponding to this butterfly, let us write down the equations and find out the answers. So at the first stage, S1 of 0 is the output of x of 0, that is of the first line. So let us see the flow. S1 of 0 has inputs from x of 0 and another input from x of 4, that being multiplied by w8 raised to 0. So finally we write the equation as S1 of 0, that is x of 0 plus w8 raised to 0 x of 4. The value of x of 0 is 1 by 2 and w8 raised to 0 into x of 4, that would be 1 into 0. Finally gives out to be 1 by 2. Let us see S1 of 1. S1 of 1 is receiving input from x of 4 and x of 0. But remember, x of 4 is multiplied by this factor and minus 1. So the equation would be x of 0 minus w8 raised to 0 x of 4. So that is half minus 1 into 0. Again we get the answer 1 by 2. For S1 of 2, the input is x of 2 and x of 6, that is x of 6 multiplied by w8 raised to 0. So the equation turns out to be x of 2 plus w8 raised to 0 x of 6, that is half plus 1 into 0, again gives us half. Similarly, S1 of 3 we can write the equation as x of 2 minus w8 raised to 0 x of 6, that would give us again half minus 1 into 0, that is half. For S1 of 4, the equation is the input receiving from x of 1 and x of 5. So x of 1 plus w8 raised to 0 x of 5. The thing here is x of 4 to x of 7, all the values are 0. So all the values will be half. So x of 1 is half plus w8 raised to 0 1 into 0. That would give us again half. S1 of 5 is receiving input from x of 1 and x of 5. That is x of 1 minus w8 raised to 0 x of 5. Again we get the value as half. Similarly for S1 of 6, the input is x of 3 plus w8 raised to 0 x of 7, that is half plus 1 into 0, which is again half. And for S1 of 7, the input is x of 3 minus w8 raised to 0 x of 7. And again the value is 1 by 2. Thus we complete the first stage of computation.